Having discussed motion of an object down an inclined plane, let's look at motion of an object up an inclined plane when a force is applied onto this object up an inclined plane. Before we think of the force being applied to move it up an inclined plane, let's look at the various forces which act on it because of the weight of the object. So mg is the weight acting in the downward direction perpendicular. It will have two components, mg cos theta and mg sin theta. We know mg sin theta will act along the inclined plane in the downward direction, mg cos theta perpendicular to the inclined plane, and the normal reaction R acting vertically upwards. Now let's say we have applying a force F at an angle beta along the some angle. Let's say this is F being applied. This is force F, and since this force is taking this object up the inclined plane, the frictional force Fs will act in the downward direction as shown. Coming back to this force, it will have two components. A component which is parallel to the inclined plane and a component which is perpendicular to the inclined plane. So if I call this angle beta, then this will be F sine beta and this is F cos beta. And now if you take equilibrium along the y-axis and the x-axis, so let's say we look at equilibrium along the y-axis. That means the object is on the verge of moving in the upward direction, so it is in equilibrium. All the forces are equal to each other if you consider the directions. So let's look at all the forces along the y-axis. So we have R, we have F sine beta, and we have mg cos theta. Now R and F sine beta, so R plus F sine beta, both of them are in the same direction, is equal to mg cos theta. So R plus F sine beta is equal to mg cos theta. And if I take along the x-axis, then the various forces that come into play are F cos beta, Fs, and mg sin theta. And we can see mg sin theta and Fs are in the same direction. So mg sin theta plus Fs is equal to F cos beta. Now we know that F, frictional force Fs, is equal to mu into R. That will be equal to mu into, if I take the value of R from equation 1, let's call this equation 2. If I take the value of R from equation 1 and put over here, I'll get mu into mg cos theta minus F sine beta. So Fs is equal to this, and if I call this equation 3 and I take this value of Fs and put in equation 2, then I'll get mg sine theta plus Fs is there, so for Fs I can write down plus mu mg cos theta minus mu F sine beta is equal to F cos beta. So after using these three equations, I have got this equation, and now I will make F the subject of the equation. So I will get mg into sine theta plus mu cos theta is equal to, I am taking this on the right hand side, so F I can take out common. I will get cos beta plus mu sine beta. Of course, I got this over here, and therefore I can write down F is equal to F is equal to mg sine theta plus mu mg plus mu mg cos theta over cos beta plus mu sine beta. And this becomes one of the important equations for the value of F. So this is the force required to move this object up an inclined plane. Now if I take this value of mu s is equal to tan theta s, where theta is the angle of friction. Then Fs will become equal to F is equal to mg sine theta plus mg tan theta s into cos theta s over cos beta plus tan theta s to sine beta. Now this I can take as mg sine theta plus sine theta s over cos theta s into cos theta divided by this is equal to here is equal to cos beta plus sine theta s over cos theta s cos theta s cos theta s into sine beta. And now cos theta s will be the LCM over here, cos theta s will also be the LCM here, so it will get cancelled out, and cos theta will get multiplied with sine theta. Here cos theta s will get multiplied with cos beta, and therefore this will become equal to mg into cos theta s sine theta plus sine theta s cos theta in the numerator, and in the denominator we will have cos beta cos theta s plus sine theta s sine beta. This is equal to F. And now using equations of trigonometry, we will get F is equal to mg into cos theta sine theta s plus sine theta s cos theta s is equal will be equal to sine of theta plus theta s, and this will be equal to cos of beta minus theta s. This will be F, and we get this equation F. So I get this equation for F the way we got for motion down an inclined plane, mg sine theta plus theta s upon cos beta minus theta s. And as we did in the previous case, if we want F to be minimum, then for F to be minimum, the denominator has to be maximum. So cos beta minus theta s, that has to be maximum, and the maximum value of cos is 1. Therefore beta minus theta s is equal to 0 because cos 0 is 1, and therefore I will write down beta is equal to theta s. So when the angle at which the force is applied, which is beta, is equal to the angle of friction, minimum force is required to push the object up the incline, and in that case F minimum will be equal to cos beta minus theta s. This will be equal to 1, so that will not be in the equation, and F minimum will be mg into sine of theta plus theta s. So this is the minimum value of force required to push an object up an inclined plane. Right, so we have looked at this. The main formula is this F for this, and once again I want you to be clear about these three angles: theta s, theta, and beta. Theta is the angle of the inclined plane, beta is the angle at which the force is applied, and theta is the angle of friction. Thank you.